Really want to thank everyone for the time. My name is Leo Chavez. I'm the founder of Enterprise IT Solutions. We're on number 10. This is the 10th webinar. So again, really appreciate everyone who's been continuing to attend these as we've been having them. We've got a great topic today with SSL decryption. Talk a little bit about how we can enable you guys to achieve your SSL decryption goals using Palo Alto networks. Carl Frey has put together a incredible presentation for us. Carl, really appreciate you doing this. We've got a little little incentive for those of you who have joined for the 10th anniversary here. We're going to be giving away some free t-shirts. We're going to draw a random name and someone's going to get a $100 gift card. So for those of you who are interested in getting a cool t-shirt here that we've put together for you, just drop an email over to info@eits.com with your information where you like it shipped to, and we will get that sent over to you. And whoever wins the $100 gift card, we will be in touch. So that said, I want to hand it over to Carl. Thank you very much.
Thanks, Leo. Hey, good morning, everybody, or whenever you watch this video, good evening. My name is Carl Frey. A little bit about me. I'm a former Marine. I have a financial and healthcare industry background with a focus on infrastructure and security. I'm a big fan of open source. I believe in a zero trust model when building out technologies. I tend to grant privilege and access as needed versus just everybody getting admin rights or excessive permissions right off the bat. I also believe in the KISS methodology and keeping it simple. Okay, and also my demo is not going to meet all of Palo's best practices, but it's a starting point for organizations, right? Some visibility is better than no visibility when it comes to SSL, right? Okay. So we'll get started right off the bat. We'll say, what is SSL and why do we have SSL? Okay, so my definition is SSL it stands for Secure Sockets Layer, and it's the methodology of securely passing traffic between a client and a server. Okay, it's been superseded by TLS or Transport Layer Security. Okay, but we still reference the encryption process as SSL. It basically starts with your public and private key pairs, negotiating a key session between, again, that client and the server. It's that secure communication. That is really at the heart of it. That's what this means, okay? And from an end user perspective, in your browsers, it's that green lock or the connection secure reference that you see. And we'll talk a little bit about the prevalence of SSL. I've referenced Google stuff. There'll be some links at the end of the slides. But, Google's traffic, okay, in 2014 leveraged SSL 50% of the time. Okay, it is what it is. It's just a number. As of October of this year, Google's traffic itself leveraged 94% SSL, right? Big change, big difference. According to Google, the percentage of pages loaded for US web traffic is 88% encrypted versus 68 in 2017 and 56% in 2016, okay, and 45% in 2015. So obviously it's growing up. It's not gonna decrease, okay? So achieving visibility into this traffic is important for organizations. I've seen organizations with 80% of their internal traffic encrypted, okay? So some organizations are following those best practices and ensuring that those communications, again, they're protecting the client and the server. Another thing that you'll want to know about SSL is how we achieve this. And the way we achieve it is with certificate authorities and their issuing subordinates. They will broker the certificates that allow for secure transactions. Okay, I would say to you, know who your CAs are and how they got there. Okay, Windows comes with a fair amount of CAs in their certificate store. Okay, there's other technologies that also have standalone stores, right? Whether that's Ubuntu or your favorite web browser. And I've seen with organizations, they have all these wonderful tools, these fancy security tools and these great proxies. And I would ask you, can you leverage all of them? Are you getting the most ROI from them? okay? The RSA conferences and other security conferences, they really appreciate you going out and purchasing, the next whiz-bang thing, okay? But again, I'll go back to my introduction when I said, the KISS methodology. Keep it simple, okay? The Palo Alto next generation firewall, easy for me to say, it can perform decryption in the forms of SSH proxy. It can do it on inbound traffic as well as egress traffic, which they call SSL forward proxy. They can do so in layer 2, layer 3, or virtual wire mode. All right, so you want to do certificate authorities right, okay? And doing that means it's not only web traffic where crypto is involved, okay? So a few other common use cases are your smart cards, your RDP or VDI sessions, data at rest, electronic signatures, and other identifying means. So the certificate authority is responsible for divvying out the certificates, right? You have to meet a bunch of criteria and it divvies them out. The next part I would say is do it right is get your private keys on a separate device. The best practice is to store your private keys on a dedicated device. You'll hear the terms HSM, which stands for Hardware Security Module. And I would ask you, so, as security professionals, it's been beaten into our heads about protecting the keys to the kingdom, right? And I would ask you, do you know where your organization's crypto keys are, right? We've seen people put their keys on a local machine. Sometimes they'll do offline USB storage. They'll throw it in a safe. Sometimes they just put it in a file share. From a file share perspective, it's a great place, for other people who are interested in taking your keys, SSH keys or other keys, and having access to them. Now they can impersonate you, okay? When it comes back to your certificate authorities, it's important that from an operational perspective, that when they're built out and they're tested, that they're also secured accordingly. And I would ask you, have they been blessed by security and the appropriate compliance folks, and have they determined them to be compliant and secure before implementing? You want to do this one right off the bat, because you don't want it to come back, after it's been in production for a while and they have all these ideas for you to, air quotes, secure it. Now, it might break your CA or your issuing subordinate, and that doesn't help anybody out, especially once it's into production. These almost have to be rock solid security appliance like features. So also of importance is your cryptographic policy, okay? So the things you're going to want to talk about or think about are your key lengths, the approved ciphers, the algorithms. Do you have to achieve FIPS or maybe non-FIPS standards? From a revocation perspective, do you leverage only CRLs? Can you use OCSPs in conjunction? What kind of certificate attributes, the expirations, how long can they last, as well as key rotation requirements. So we'll go through a little bit of this from a Palo perspective, but my suggestion to you is think about these things, document them. EITS, we can help. We are proponents of proper PKI and setting that first, and then everything gets built off of that, right? Your NAC solutions, everything is built off of that. Okay. So not a crypto policy specific, but really from an HR standpoint, I would ask, will HR support when you quote unquote intrude on end users? Okay. What can't you decrypt of user traffic? I've seen this before, right? And everybody says, oh no, they have a acceptable use program and we can monitor everything that you do. That's great. That sounds good from an IT perspective until there's an issue and HR gets involved. So typically financial websites, healthcare websites, they are off limits. Those are left alone. And I would also say, what should an end user see if you are going to decrypt their traffic? Should they have the ability to opt out? Should you just post something up there and saying, yep, it's an awareness thing, we know it, and they have to hit continue, okay? So more crypto, symmetric versus asymmetric keys. Can you use the same encryption, can you use the same key for encryption and decryption? That may be acceptable, it may not. Or are you to only use public and private pairs, okay? And do those public and private pairs, are those internal certificate authorities, or would those be your external ones like the VeriSigns and GoDaddies? So you guys see up on the right-hand side of my slide, there's a message that Palo produced a little bit ago, and they said, hey, Google is going to, for all of its apps, it's going to mandate TLS 1.3 in January, okay? And if you are doing SSL forward proxy with Palo or maybe even other tools, you may want to be prepared that your device can actually handle that traffic type. So now we'll come to where should SSL decryption take place, okay? Regardless of on-prem or in the cloud, there are solutions dedicated to take on the tasks of decrypting traffic and properly storing keys, okay? So, we'll talk about Palo Alto today. So Palo Alto does a couple other things other than decrypting the traffic, right? And I'll go through a little bit of that. And that is, they can perform SSL decryption offload. So they'll offload decrypted traffic to other security tools, which can analyze and return traffic on the appropriately sized appliances, okay? So for me, in a past life, I did FireEye stuff, right? And FireEye couldn't do native SSL decryption, right? And that would have been nice if we could have said, okay, we had Palos in front, let's hand it off and return it back, right? That would have made the other tools more effective that we'd already purchased. But the other thing it could do was leverage the decryption port mirroring on the Palo, and that enables the firewall to create a copy of decrypted traffic and send it to a traffic collection tool for analysis and archiving. So I mentioned HSMs previously. I'm just going to talk about them for a moment to give you an idea of what they are and how you can leverage them. Okay, so the Palo Alto can leverage them as well as far as keeping the keys to the kingdom on the actual hardware security appliance. Okay, and this can be used for a plethora of other use cases. The HSMs. We'll have a future webinar on them. So HSMs are dedicated security appliances. Some of them require a card set to access, and you'll have to interact with the machines physically for some of the functions. Okay. Your private keys will be encrypted and can only be accessed inside the HSM only and never leave that machine. Okay, you're not exfiltrating them. Thus, if any other machine wants to use it, for signing or etc., they have to use a particular API connected to the HSM and let the machines do that. So HSMs can be used by many other devices outside of the Palos, right? So you can use them for more things. The machines themselves are protected using hardware tampering models. So for some of you guys on the government side are hip to that, think varying degrees of FIPS accreditations. It will activate the security protocols when someone's trying to open the machines illegally. Maybe illegally is not the right word, but inappropriately or, not the vendor. So you can't dump the memory or even read the disk intact at that point, okay? And so whether you're a Linux guy or a Windows guy, the pseudo-random generator is somewhat, it's one of the most widely used algorithms in the world today, okay? Mouse entropy, that might ring some bells. And however, the term pseudo, just that means it's not exactly random. So getting randomly generated information can be achieved with an HSM. All right, enough on the HSMs. One of the things I see in my role that customers struggle with is where to use decryption. Okay, do you do it for inbound traffic? Do you do it for outbound traffic? Do you do it for Windows endpoints? Do you do it for Windows servers, Linux servers, appliances? Where do we do it? And they kind of get stuck with not moving forward, right? Small wins, people. And then I see on the negative side, I see, certain things missed, okay? And those certain things are your mobile devices, okay? It's a BYOD world. It's a mobile device world. If you haven't gotten to that in 2018, it's coming. So I would say, how are your mobile devices handling encrypted traffic? Okay. Do you have any visibility or metrics on those mobile devices? So I would say extend your traditional data center, your cloud environment, or your physical branches to account for all of your company's assets, not just the ones that are easy or on-prem. You may achieve this with a always-on VPN awareness, and that always-on VPN could be on the endpoint, the workstation, laptop, or it could be on the mobile device. And then I would ask you, for your mobile devices, do you know where your client-side certs, the embedded certs, those apps that have embedded certs? Do you know where they're at? Okay, it's really problematic when you start doing SSL decryption and you have certificate pinning. And if we have time, we'll go through a little bit about SSL exclusions. But that is a thing. But again, it all requires testing and awareness. So I say this, right? We focus on the endpoint because that's where we think the end user is going to get phished. They're going to click on a link. They're going to do something evil, or they're not going to do it evil, but something evil will result. I would tell you this: servers are not special snowflakes. Okay, you can decrypt their hosted inbound traffic, right? You provide a service to the general community, right? And as a result, there's a trust between the client and you, the host, and providing that service. So if somebody was to do something malicious or egregious to your hosted app, can you see that, right? Defense in depth. How is that application logging and protection? How is that app protecting itself? Is it, are you not setting on your laurels? Are you depending on security through obscurity? Okay, I hope not, right? So decrypted traffic, for your own traffic or for your own hosted apps is pretty important. Is your application logging your primary measure against application attacks? And if that's true, okay, so be it. How long does it take for your SIM to correlate that, or whatever third-party tool that you're using? Okay, and I would say all of those fancy IPS devices that you have, okay, and yet you can't see your own hosted traffic. I mean, that doesn't seem a good use of your company's resources and your time. And from a server perspective, decrypt their outbound traffic, right? Why are servers making outbound calls, right? Maybe for updates. Who knows what they're doing. But I would also, warn you. There's a fair amount of breaches that have occurred where exfiltration actually occurs on the server itself. And, we kind of say, oh, that's no big deal. Nothing bad can happen. I've also seen it in a air quotes secured environment that the server environment didn't go through a proxy properly and had access to the internet. That's where folks went to, surf Facebook at the time, right? Not good. This is not good. So more on, kind of make you feel bad or, warn you. Test, and test some more, okay? We'll follow a waterfall methodology after doing your proof of concepts and, make sure you're still looking at your endpoints to see how they're behaving as you keep rolling it out through the waterfall methodology, as well as look at the crypto resources behind the scenes. You're applying additional load to them. How are they behaving? Are they within specs, right? Maybe not. All right, so we'll talk about the demo I'm going to do. These can be quick wins. This is not a best practice, but it can give you an idea of, getting some quick visibility right off the bat if you're not doing so already. All right. All right, so I've got this website here, right? And if you guys haven't heard of ICAR, it's just an easy way to test, a malicious file. And there's a couple. I'll scroll down a little bit, and there's a couple ways that you can access them, right? So we will start out with clear text with HTTP, right? So the first thing I'll do is kind of back up a sec. At the border, in this demo environment, there's a Palo Alto, and that Palo Alto can see this traffic because it's clear text. There is no SSL decryption taking place, so it will not be able to see that. We'll prove that. So I'm going to download this file right here, this known bad. Oh man, look at that. So right away, it can be seen, right? You guys acknowledge that. So right now, I'm going to do the same thing. I'm going to click on, this was also bad, right? But the Palo didn't see it. And the reason it didn't see it was secure. So right here, I can actually download, as a normal user would be able to, something malicious and evil, okay? So let's go and look real quick. Let's see if we can see this traffic. All right. So just big picture, work with me here. I have a column here that says, hey, is it decrypted? The answer is no. I have obviously this query built out. This is just us. And I can see, hey, I've got some SSL traffic going. Not sure what's in it, but at least here I am aware that this is traps management and SharePoint. Great, but a lot of it, I am not sure of what that layer 7 traffic is, okay? So what we're going to try to do is get some awareness around that layer 7 traffic. All right, and the first thing that it starts with is with our certificate authority. I'm going to make this Palo Alto be a certificate authority. So the first thing I'm going to do is start the process of generating that. I'm going to call this guy, I trust him, but I don't trust myself to type. And I'm going to call him, let's see, what is my IP? 10.201.2. You should use FQDN. I can't have the E capital I, sorry. It's going to act as a certificate authority, right? Remember those crypto policies? All of these things mean something as far as, what are our allowed algorithms? How should this certificate authority sign things, right? All of these values, they come back to life here, right? How long should the certificate be good for, right? The certificate attributes, right? I like, all these are important, but I personally like the email one myself. You may have other standards that you have to fill them all out, and that is good. That's not necessarily a bad thing. But, I would say, if there's an issue, who do we want, to contact? Is it the help desk? No, let's make this the real guys. We'll make this the network admins at yourorg.com. Oh no. There we go. Let's try this now. Cool. All right. So we got to go back into and say, what is that cert going to be used for? And I'm going to use this one for trust certificates, forward trust certificates. All right. And when we get back into the demos, this might make a little bit more sense. So I'm going to create another one. I'm going to call this one my Untrust demo. It too is a certificate authority. And, you know, if someone were to look at this, who do I want them to call? Not the network admins. No, sir. Call the help desk. Although I can't type your org. Let's try that. Let's try that again. Cool. I want to look at this. I want to select that. All right. So again, this is not exactly the best practice as far as running certificate authority from the Palo. A lot of folks do it, right? And obviously I still can't type here, so we'll roll with that. Not as important for this discussion, but obviously QA your work a little bit better than I am right now. But again, this is a starting point. You know, getting that visibility is a starting point. All right, so remember when I told you, hey, we got to do this non-sexy stuff, and we've got to figure out all of the crypto that is allowed or not allowed? That's here, right? All of this stuff comes to life. It's important. You know, are we going to allow RSA to be exchanged? You know, triple DES, probably not really a good idea anymore. RC4, not a good idea anymore. So depending on what your organization wants, you may have to account for this accordingly, right? And this will come into play in just a moment, but I just wanted to show you how all of that planning that we just said will come back to life or come back to haunt us if we don't do it right. All right, let's start decrypting. All right, so the first rule, firewalls will process from the top down, but the first thing what we're going to do is actually not decrypt traffic. Okay, we're going to have a no decrypt policy. And, you know, this was, remember, this was the healthcare and finance, right? So let's do that. I'm going to give it a tag. For this, it is just my demo. And, okay, remember that waterfall methodology. Let's walk this out. Let's start slow. Let's start small, and we'll bridge it from there. Okay. For us, I've created an object. This is us right here. This is our test machine. And where is that test machine going? The internet. Okay, so again, this will be our exclusion rule, right? So let's find finance. Let's try to type finance. Right, and then it was it health and medicine? Yep. All right, so what we're going to do is then we're going to come over here and we're going to say, we're not going to decrypt that traffic, right? However, our company policy is it has to meet these standards right here. Remember that? Okay, so we're still going to hold them accountable to that. All right, fantastic. So next one is, this will be our actual decryption policy. Same thing, I have to pick, you know, where's my traffic originating from? For me, this is in the DMZ, and that is my source address. And again, everything will be egressing out to the internet. And from here, what categories or, what service, I want it to be everything. So I'm not going to make any changes here. And then from here, the action that I'm going to perform with this rule is I'm actually going to decrypt it, okay? And I want you to adhere to my my decryption profile settings that we just looked at a few moments ago. And this is the type, right? So we talked about like the SSH and the inbound. This is where you could set that up right here, okay? So for us, we're doing the SSL forward proxy, all right? All right, let's see if I screwed something up or not. Let's run a commit. Let's see if it barks at me. All right, well, it's not yelling at me yet, but one of the things I wanted to share with you as far as SSL decryption, in a past life, I worked at a organization, and they had some devices that were doing SSL decryption, and all of the internet traffic was running through it. And when they would turn it on to decrypt very specific traffic, it broke unrelated traffic that depended on encryption, right? So for us, that was for SMTP, right? So that outbound SMTP was broken, and if I remember correctly, it also broke OWA, right? So that was pretty problematic, and there's nothing like being accused of something like, hey, someone's stopping us from being able to securely send this traffic, and you, as in the security team, go, no, it can't be us, right? Because we're not decrypting that traffic. And I bring that up because it was painful. It was painful from the standpoint of the maintenance sessions. Like obviously, we can't always make changes in the middle of the day, right? So it's got to be during the appropriate maintenance window. Packet captures get done. You send it off to the vendor. You review it yourself, and you go, I don't see anything. Oh, we have to do this again. We have to gather more information. Crawl, walk, run, right? Test accordingly. Get a proper test environment, right? Not overrated. All right, so what I'm going to do is I'm going to take those certs that we created just a few moments ago, and I'm going to get them out on our test machine, okay? So this is our, whoops, I don't need that. This is our good cert, and then our Untrust cert, and we'll go into that a little bit in a moment. I'm going to export that. And I'm also going to export that guy. All right. So bear with me. Behind the scenes, I need to move it. Okay. Proper machine security. It needs my password again. All right. So I have these certs. I'm going to take them. This is what I just exported, and I'm going to do something with it, right? I'm going to put it on my endpoint here. Okay, so now we have to say, what are we going to do with those certificates, right? And there's different things that we can do. We can manually hand jam them in. We can script them. We can use GPOs. The world is your oyster, okay? But for this discussion, I'm just going to manually import them into the certificate store for Windows that I already have open, right? So I want that trusted cert. Okay, I'm going to put it in the appropriate place. And here we go again. Well, I guess I could click OK. There we go. I'm going to go back to this website, and I'm going to say, all right, cool. Here it is again. So we have iCar, right, in the zip file, and we're going to download it in clear text, and it will be stopped. Why? The Palo sees it. No big deal. Cool. So here, I'm going to try the same thing again. I'll do it over a secure protocol. And oh, this is not good. Man, we don't like our users to get these messages, okay? And so the reason this browser is doing that is because the Firefox browser natively does not recognize the Windows Store, okay? So we've got to go into it and import that certificate. Boom, that certificate is trusted. Let's try this again. Now it detects it as being evil, right? So that's cool. Let's look at that real quick from a traffic perspective. Let's see. Let's go back up to our firewall. Let's see if it looks any different. All right. So here, right, we now see that there's decryption taking place, right? You guys see that? In addition, remember here before, we were just seeing was SSL. So from a layer 7 perspective, we weren't detecting all of the layer 7 apps behind it. But here, right, here's an example. Now it's actually being detected as pure web browsing. Pretty important to note, you know, as you further mature your traffic awareness and also your rule awareness. You know, you could say, hey, I'll let users get to Facebook, but I don't want them to pull Facebook or get to Facebook chat, maybe something like that. All right. All right. So we'll get back on our endpoint. I've got another website I want to look at, right? And again, this is a website, right, that I don't want my users going to, right? It's a bad website. Behind it, there's bad crypto, okay? So you're not going to see this terribly often when you do SSL decryption, right? But, you know, we've talked about it internally. This goes back to your policies. This is the importance of policy. What do I want users to see? Do I want my users to get to this website regardless, or do I want to stop them dead in their tracks like they are right now? So for us, this goes back to, remember that untrust, sir? That's this guy. That's a forward untrust. All right, I'll trust him to identify websites. Let's come back. Boom, it loads, right? So this is a policy thing. Now, we can debate if you should have let users get to sites that are inappropriate on the back end, crypto-wise. Different discussion. I don't disagree. All I'm saying is it's a discussion that's worth having, okay? There's that. Let me show you one other thing. So I was telling you earlier about like embedded apps, right? Or like PIN certificates. So I've tried to do SSL decryption. I successfully achieved this, and as far as decrypting mobile phones. Okay, mobile phones in their own little weird way, a pain in the butt. There's so much certificate pinning of the apps. You know, hey, we want these secure you know, app stores and iTunes. Great, fantastic. It comes at a cost. There's administrative overhead to account for them. So if you run into organizations or apps that you have to exclude from being decrypted, here there is a process to exclude them, right? And I just happen to put Apple in there because Apple, especially back in the day, was pretty horrific with the amount of the URLs that had pinning behind them, right? Pretty obnoxious. So let's see, what else? Did I give you everything I said I was? Yeah, we found malware with it encrypted. Oops, excuse me. We prayed to the demo gods. They were pretty merciful. And so big picture, my demo was pretty straightforward. My presentation was pretty straightforward as far as, you know, there's a lot of background that goes into all of the work that goes into leveraging crypto in your organization. And it's the tip of the iceberg because, you know, we can do code signing. There's so much we can do with certificates and crypto in general. So I hope that this was helpful. I wish you luck, and in your hunting. And I would ask you, do you guys have any questions? And I don't have the chat in front of me, so if anybody has any questions, the panel will.
Got some good questions, Carl, and I'll kind of roll through them here. So we got a couple from Mike B. Here it goes. So we have an HSM, had it for years, and we use PKI pretty well. The issue discussed here, I call it certificate pinning. Makes it very hard to get man in the middle to work properly. How can we make sure our man in the middle works as Google and others keep moving the PKI chess? And he had a follow-up to that. More detail on pinning on PCs. We provision and completely manage things. It works pretty well most of the time. On mobile devices, particularly on the guest network, the rate of change in the endpoint and apps tied to new technologies to offer security as a feature means we have not been able to decrypt a lot of the traffic. Too many apps, they break too often. This leads to a point where our decrypting visibility has diminished, and it's been tough lately.
Yeah. So it is hard. And so this goes back to the test. And maybe on guest wireless, you don't do it because those might be assets you don't control. And I take the stance, if they are your company assets, then you control them, you control what they go to. So I would say, your certificate authorities, your internal ones, okay, your trusted ones, your trusted third party, you should be aware of them, and you should be able to decrypt traffic accordingly. The certificate pinning, it sucks, right? It just requires testing and a proper rollout. So I can remember that, hey, we'd make some progress. I'm not aware of anything off the top of my head as far as, hey, these are the known bad top talkers, if you will, on certificate pinning. But literally, it's practice, and it's testing. That would be my suggestion.
And I would say, what I've seen with the team is the more they do it, just beating at this for years and years and years in different customer applications, the better they get, the quicker it is. So it's a troubleshooting process. It really is. And Carl hit the needle on the head, just making sure you really test thoroughly and know what you're going up against and be prepared for whatever may come up in that front. Another thing I want to add on that note is we've been talking internally about doing a 2 or 3-part series focused on doing decryption the right way. Really maybe having a session focused on HSM and, the gotchas you need to know around that, and, architecturally, where to get started and how to do things the right way from our experience. Maybe one focused on applications and common issues we're seeing and troubleshooting techniques that the guys have picked up over the years. But I'd encourage everyone on the webinar and those that watch it later, email us, info@eits.com. We want topics that are relevant for, what the community is seeing and are going to be meaningful for attending. So we welcome your feedback on that.
So, let me just kind of go back to it. So we talked, when I was going through some of my slides, I talked about, how MDM, is a opportunity and a problem, right? So in this scenario, maybe if you're evaluating MDM solutions, right, you say, hey, I need that visibility back on that endpoint to say which apps are installed, which are sanctions, which are not, right? That you can go through that and say which ones have app pinning or certificate pinning to the apps, right? And that might help enable you, right? Not the caveat, but the usage of the guest network, that's the wild, wild west. Right. So I don't know what to tell you on that one, because you could have, Joe Schmo coming in off the street and you don't have control over that endpoint. And at that point, what you're going to encounter, I don't know. My suggestion would be if it's that problematic, maybe take that traffic away from your current production, internet traffic, dedicated DSL or something like that, and shun them off. Don't let them ever come close to touching prod. So That would be my suggestion.
No, that's a good point. I mean, segmentation really starts to come into play there.
Yep.
Where you don't have those capabilities 100%. All right, I think we might have one more here. Okay, cool. All right, well, good feedback. Good feedback in the chat window. Good questions coming up. So unless anyone has anything else, I think we're ready to wrap this one up. Carl, really appreciate it. Great job. I know I found a lot of value out of that, and I really appreciate you taking the time to put this together for us. Actually, wait a minute. I got one here. I think Walker's got one.
Yeah.
I see something coming through on the chat window.
All right.
Putting them on the spot here. Type fast, Walker. So when decrypting Gmail, can we block attachments?
I believe so. Yeah. Well, hold on. Gmail, yeah, 443, right? You're not talking about using it over a client like a native SMTP. It would be pure F443. So you should be able to, and I don't think it's so much. I think this would be. Let's see. I would think that is actually Applepedia, right? And I would, let's see. I would ask, you know, on the Google front, let's see what apps it knows, what it can see. I mean, the fact that you can decrypt it is the first step, right? And then the second step is, you know, what is inside of that traffic, right? So I don't know. Let's see what layer 7 awareness we have here. So I just, obviously you saw me quickly look at, yeah, you got Gmail downloading right there. So looks like out of the box, you can do that with layer 7.
Hey, Carl, can you kind of the 30-second overview of you know what the Applepedia is for anyone that may not know?
Yeah. So Applepedia, it's easy for me to say again, is Palo Alto's all of the applications that they are aware of. So within SSL or other protocols, there are actual specific apps that are taking place. The Facebooks, the Gmails, as you can see here, and then obviously there's major categories or subcategories. They'll provide at a risk. I like to be risk averse. And so anything that's a 5, which nothing is from a Gmail perspective, I like to handle those applications differently. I'll pay attention to them a little bit more. And, I'm a little bit more risk averse than maybe the average bear. But from this perspective, all I did, right, I'm looking, we'll take this out. Here are all the apps, okay? And you can look at, based on their, I know you guys can read these columns, right? The characteristics, the risk, what technology areas they're in, and based on the category and subcategory, you can shape traffic. Shape traffic is not the right word. I would say control it, right? I'm going to allow it through, or I'm not going to allow it through, right? Whatever this guy is, let's click on him. 100 treasures. Yep. Free Chinese peer-to-peer. Probably bad. Right? So I could say, hey, I'm going to look at all my risk 5 apps, and I'm going to do something with them. I'm probably going to block them, and I'm going to whitelist the known good ones that I know are acceptable. And all of that comes with awareness coming back on to your traffic, right? So that's where this really comes in handy here as far as know thy traffic. Let's see if this will update anytime soon.
And hey, Carl, we got a little bit of a little more details here from Walker. So to add to his question, is there a Gmail upload app we could block? A Google Drive app breaks with decryption? So there's some pin cert that they don't know about somewhere.
Maybe. I mean, obviously it goes into testing. So yeah. I would ask you this about, let's look at Gmail real quick. Let's go back to this. Well, actually, not here. I want to see if, I want to look somewhere else first. I'm just curious, big picture, is Gmail excluded, by default, right? And I don't know the answer. Typing's hard. Typing's really hard.
And Eddie's saying you should be able to block using, block Gmail using file blocking.
Oh, yeah. So if destination's Google, don't let certain things go through. Yeah, that makes sense.
Or at least getting the additional inspection if you wanted to decrypt it by applying the policy. So yeah, we got one more. So we're discussing what's the best. I got one more from Corey here. So since we had Apppedia up, what's the best way to handle traffic that's being tagged as a specific app, but it's being blocked as it's using a non-standard port? Application override is the only thing I'm aware of.
Yeah, that's it. Yeah, so that, well, not really. That goes into the way your rule is created. So I take that back, right? So you could say, for that particular traffic, I'm going to let it be on the application defined service, or I'm going to create an exception for it. Did you have something different, Alex?
Yes. So what I would do with that specific scenario is you can do an application override, but you got to be careful, because whenever you do an application override, right, you're basically dropping it down to layer 4 inspection, because you're assuming you know the application, and it's going to assume you've already identified it at a layer 7 perspective. So you get more the layer 4 stuff. Now you're still going to get your IDS and IPS and all the fun stuff with that. But really, Carl, if you can open up that policy, I'll show you where I would go in here and I'd actually do that. So if you go into this policy, and we go into destination, which, you know, it'll pop up here eventually. We're going to go to destination, and you're going to have, there's also this category, and inside it right there. So go to services URL category. So you tag your destination, and your destination might be, you know, that application you're using on a non-standard port, right? And I would go into the services profile here. And then what I would do is, instead of saying application default, I would actually customize it and choose what standard ports I know it's running on. Now, if you don't have an idea of what standard ports it's running on, you could always open it up to any, although that's a bad practice. Even though it will identify the application, you really don't want to open it up for everything. A lot of times you have a specific reason for, I want to open it up on these specific ports because vendor X told me these are the ports that our internal organization is going to use, right? And what you do is you create a service profile. And with that service profile, you say, these are the range of ports, or this is the single port, or this is the multiple ports, right? And that's how I'd handle that. And basically it goes back to just the default.
That's a more eloquent way of saying it than I was trying to. Thank you.
Good, good. So,
and forgive me, I have browser. The demo gods are not speaking to me because my browser.
The demo gods were good to you. We just stepped you outside of the demo, you know. And guys, that's what happens when you got, you know, an engineer running the demos, where, you know, he wants to dig into it just like you do. So no worries. We stepped outside of what was planned with the gods. This is good. And one other thing Jason threw out in the chat window regarding the Google attachments, just validating what Eddie said there on file blocking. You'd also use that in case you were using a third-party webmail that doesn't have the granular layer 7 apps. So you use the file blocking feature. All right, everyone. Got 5 more minutes left. If anyone has any other questions, feel free to toss them out. But outside of that, I think we're good to go. This was a good one. And like I said at the beginning, if anyone missed it, if you want the free shirt, email us info@eits.com. We will just send your mailing address you want it sent to, and we'll get it shipped out to you. Carl, you got anything else before we wrap up?
No, just thank you for joining, and thank you for your time, everybody. I appreciate it.
Agreed. Thanks a lot, everyone. Have a great weekend.
Thank you.